So open VIVADO 2015, XILINX VIVADO. Will take some time to open. So now it is opening the tool. Now click on create new project. Click on next. So here we can give the project name, location. So make sure that by default it is RTL project. So now we are going to write the program. So for that, create file, give some file name. So in my case, I'm going to give the file name as the R logic gates. Click OK. Once file is created, right? So synthesis and simulation by default, make it is that. Don't do any modifications. Click on next. So these are optional. Click on next. So select the board if you have. In my case, I have the Z board. Click next. Click next. Now project is being initializing. Now I'm not going to give the ports externally. Just click OK. Yes. Inside of program, I'm going to assign the ports. If you observe here under the design sources, we have the R logic gates. Click on that one. So there only we need to write our program. See, now I'm going to write the program for all logic gates, right? So for that, I'm going to consider the ABR, the two inputs that is common for all logic gates. Output will be declared by the different variable. So we have 7 logic gates. For that, I'm giving the Y1, Y2, Y3, Y4, Y5, Y6, Y7. So we are telling that these are the ports we are using in the module. Now we need to tell that module which ports we are using as the input as well as the output port, so that only module will understand. So in this case, I am going to use the input as the keyword is input. See that all keyword is in the highlighted color. So AB are the input ports. The ports AB are going to be declared to the module that we are using as the input ports. So once after input port declaration is completed, now we need to declare the output ports. So how many outputs we have? Y1, Y2, Y3, Y4, Y5, Y6, Y7, right? So just I'm going to copy that one, paste here. Now I have done here mistake is twice I have given Y1, right? So just I'm going to change to the Y2. Done. So declaration of the output ports also completed to the module. Now what we have to do is that, so here I'm going to write the program in terms of the data flow model. So declaration of output ports to the module completed. See that we are writing the data flow model. Data flow model means we can tell in terms of the equations. So for that we need to use the statement is the assign. So first logic gate, here I'm going to use the AND gate. For that I'm using the variable output is Y1 A ampersand B. See, ampersand only it will understand, so that language parameter you need to remember. So for AND gate, A ampersand B. So AND gate assign statement is completed. Now what we are going to do is we are going to write the data flow for the remaining logic gates. So after completion of AND gate, we are going to write the program a data flow model for the OR gate. So for that I am going to consider the variable Y2. So it is something like this, A, B, right? So these things you have to remember. So those things only will be understood by Verilog. So R logic gate is completed. Now I am going to write the data flow for the NOT gate. So for that here we need to use the negation. Negation means it is going to perform the NOT gate operation. For input A I am going to perform the NOT gate. If you want you can take the negation of B also. That is your wish. Now I am going to write the one more assign statement Y4. In this case I am going to give the NAND gate representation. First I am going to give the A ampersand B in that bracket. So once bracket is closed, now we are going to give the negation. Negation means it is going to perform the complement operation to the AND gate, nothing but NAND gate. now we are going to write the data flow for the NAND gate completed, right? Now we will write the assign statement for the OR gate. So likewise we are going to write for the XOR logic gate as well as the XNOR logic gate. Once your program is completed, then save the program, then click on the RTL analysis. So this is for NOR logic gate. So that cap symbol we are using for the XOR logic gate. Negation of cap means that is for the XNOR logic gate. See, that same way, instead of using the data flow, if you use and C and y1 comma a comma b, or y1 comma y2 comma a comma b, next NAND y2 comma a comma b, NOR y3 comma a comma b, something if you write like that is nothing but your gate level modeling, the simple thing. There we are going to write in terms of the primitive, here we are going to write in terms of the assignment statement. That's only different. You can try by using of the gate level modeling for the same program. Instead of assign statement, you give the gate primitives and y1 comma a comma b or y2 comma a comma b, not y3 comma a, something you give it, so that it will also generate the output. So now I'm saving the program. Use Ctrl S if you want the shortcut. Then RTL analysis, click on open elaborated design, then click on schematic, OK, then wait for some time, it will generate the AND gate symbol. See, AND gate symbol, all logic gates, sorry, not AND gate, all logic gates are the generated. See that we have two input ports AV, then all output ports. Now we are going to write the test bench. Click on all logic gates, right click, then click on add source. So here we need to select the add or create simulation source. Click next. Now if you want to write the test cases, we require the file, right? So for that we are going to create the new file. If you have add file, then you add it. If you don't have, just click on create file. It means that empty file we are going to create. So give the file name. In my case, I'm giving the test bench something. Whatever the name you want, you can give it. So once it is done, click on finish. Now here we are not going to give the ports. Directly we are going to give inside of the program. So for that I'm clicking on OK, then yes. Now see that under all logic gate we have the test bench, right? Just double click on the test bench. Inside of the test bench only we need to write the test cases. These are the following statement we need to write in order to test the all logic gates whether it is working as per requirement or not. If it is working as per the requirement, that is our final design. If not, what we have to do is again we need to go back to the program, then we need to change the program. So later on again we need to test the test cases. See, as I told that register is used for the inputs because input is holding the values. So output is just displaying, right? So for that we are using the keyword as the wire. So once it is completed, what is the next step? See that here I'm writing something like this. Storage means register, otherwise wire. Now which file we want to test? All logic gates, right? So give the file name exactly. So if we don't know, go to design source. There we have given file name is all logic gates. UUT we need to give, right, unit under test. So we need to give all the input ports as well as the output ports. UUT followed by input output ports. So AB, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Just I am going to copy and paste. Done. So once it is completed, give the termination, nothing but the semicolon. So now here what we have to do is, if you want to write the test cases, first perform the initialization operation. So in between begin and end only we need to write our test cases. Once begin is completed, now I am giving the 4 possibilities 0, 0, 0, 1, 1, 0, 1, 1. So A equal to 0, B equal to 0, right? So what is the time delay? 100 nanoseconds. It means that for 0, 0 it will display the output after 100 nanoseconds. Now see that I am going to replace 0, 1. One more condition is the 1, 0. Next condition is the 1, 1 input condition. Those are the test cases which we are going to perform the testing operation for the file name all logic gates. For last one we don't require the time delay. See, begin is done, right, at line number 27. Now we need to close by using of the end, and line number 23 we have the module started, right? Now we need to close the module. Once it is done, don't forget to save your program. So after saving, now we need to go back to the simulation, right? Save once it is completed. Now go to the left side, there you will find the run simulation. So click on the run simulation. So under the run simulation, click on run behavioral simulation. Now simulation is processing. In a couple of seconds we are going to get the timing diagram. So after checking the time diagram, if everything is okay, then that is final. We have the input ports, output ports. Click on zoom fade. Now adjust as per our requirement as shown in the diagram. Just move cursor towards the leftward direction. See that in that 0 to 100 nanoseconds, those are the input, those are the outputs. Just check as per your logic whether it is correct or not. If it is correct, okay. If it is not correct, go back to the program, then do modification. I hope you understand. Thank you.